All right, guys. Today we are starting chapter 9. We are starting chapter number 9. Yep. Skip date. We'll come back to it. What we're going over is right triangles and trigonometry. Chapter 9 is right triangles and trigonometry. Talking about sine, cosine, tangent are our trig functions. But before we get into that, our first thing we're going to cover is the Pythagorean theorem. Pythagorean theorems. The sum of the square of the legs is equal to the square of the hypotenuse. Trigonometry is the study of angles and triangles. Not too much. There's a few things that are unique to it, but we're looking at this here. So in a right triangle, the square of the legs, length of the hypotenuse equal to the sum of the square of the legs themselves, or as we are used to calling it, a squared plus b squared is equal to c squared, where a and b are the two legs and c is the hypotenuse. Now we have something called a Pythagorean triple. If a set of three numbers, set of three sides are all positive integers, positive whole numbers, a, b, and c, then we say that it is a Pythagorean triple as long as it satisfies a squared plus b squared equals c squared. Now some common Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25. So if we have these triples, we consider them to be these numbers. They work for the Pythagorean theorem, thus they're a Pythagorean triple. Now, ACT does like using Pythagorean triples, especially 3, 4, 5, in the questions. They like using these over and over again, especially if you're given cardinal directions, north, south, east, west. In a word problem, most likely it's going to be a Pythagorean triple. Essentially, if Johnny walks 3 miles north and 4 miles west, how far is he from his original destination? Side lengths of 3, 4, it has to be 5. Now, they might not always use 3, 4, 5, because they might use 6, 8, 10, or eraser, 9, 12, 15, or any multiple of 3, 4, and 5. It's still a Pythagorean triple. 9, 12, 15 is still a Pythagorean triple. We could say 90, 120, 150. It will still work, because we're just multiplying them all by 10. Still Pythagorean triple. The same is true for 5, 12, 13. It is going to be a Pythagorean triple. We're just doubling them or tripling them. Because for 9, 12, 15, we're saying that 9 squared plus 12 squared is equal to 15 squared. Well, 9 squared plus 12 squared is equal to 225. 15 squared is 225. They are the same. They're equal. We could say 90 squared plus 120 squared is 22,500 is equal to 150 squared. And it's still true. So these are kind of nice to know. Okay. Here you go. So really, you can just say any multiple of those, because the first set is just multiply them by 2, second set's by 3. All right, let's look at the first example problem. Find value of x, then tell whether the side lengths form a Pythagorean triple. So the general formula is a squared plus b squared is equal to c squared. They gave us two lengths. They gave us 5 and 12, yes? Now 5 and 12 are both the legs, and x is the hypotenuse. So we have 5 squared plus 12 squared is equal to x squared. Five squared and 12 squared are both on the same side, yes? We can plug that in. Because we can say 5 squared plus 12 squared. Clear. 5 squared plus 12 squared is 169. And this is equal to x squared. What would we do next? We would square root both sides. Because whenever the index and the exponent are the same, because the square root, the index is 2, they cancel each other out. So the square root of x squared is x. And the square root of 169, 13. So the square root of 169 is plus or minus 13. Because 13 times 13 is 169, yes? What is negative 13 times negative 13? Because the negative and negative make a positive. Now, for us, we're not going to actually consider both the positive and negative case. Because can the length of the side of a triangle be negative? No. So normally we just say 13. Because the negative 13 is what we call an extraneous solution. It is a solution that does work mathematically for the problem, but does not fit the original context. It's an extraneous solution. So x equals 13 is our value of x. Is it a Pythagorean triple? Yes, because it is 5. All whole integers, all integers, 5, 12, 13. So yes, it is a Pythagorean triple. Any other questions on this here? Yes.
So can it like be a mix of any of these numbers and it would still be considered?
As long as it's a whole integer, if it doesn't have a decimal or radical. So let's look at this one here. A squared plus b squared equals c squared. So x, is it one of the legs or the hypotenuse? Hypotenuse, and we know it's the hypotenuse because it's opposite the right angle. So c is our x is going to be our hypotenuse. We take it in place of c. A and b are 4 and 5. So we have 4 squared plus 5 squared equals x squared. Now if we did this, because at this point we could plug that in a calculator. 4 squared plus 5 squared. It's all numbers right there. The calculator will do it for us. If we did it by hand, 4 squared is 16. 5 squared is 25. And 25 plus 16 is 41. What do we need to do next? Square root both sides. Square root of x squared is x. Now we can take square root of 41. Square root of 41 is square root of 41. Or if we approximated it, it would be 6.403. Square root of 41. So, no. Pythagorean triple. Not a Pythagorean triple. Because it's a non-repeating, non-terminating decimal. Questions on this here? We ready for the next one? Yeah, you're good. I'm just find the value of x, and then we're determine if it's Pythagorean triple. So a squared plus b squared is equal to b squared. Which one is going to take the place? Is x going to take the place of a, b, or c? B. It really doesn't matter if it's a or b. It's just going to have to be one of those two. A in this case is going to be, and c is 14. Now this time we can't plug all of it into the calculator because 7 and 14 are not on the same side. Well, 7 squared is 49. And 14 squared is 196. Now what do we need to do next? Yes, we need to get x squared by itself, so we're going to subtract 49 from both sides, which will tell us that x squared is equal to 147. And then we would square root both sides. Square root of x squared is x. Second square root 149 doesn't 147. 7 square root of 3. So no. If we wanted the exact decimal, it would be 12.12435565. Yes. It would just be, look at what the directions ask. If it says round to the nearest tenth, do that. If it just says find the value of x, 7 square root of 3 is just fine. And no, it's not going to be a Pythagorean triple. Questions on this here? We're ready for the next one. So, a squared plus b squared is equal to c squared. Anybody have a guess at what b is going to be, or what x is going to be? Well, we can go on and plug this in. C is going to be 25. Hypotenuse is always the biggest side length, which means A is going to be 15 and B is X, or vice versa. Yes. 3, 4, 5, one of our Pythagorean triples, yes? What times 3 is 15? 5 times 5 is? So 3, 4, 5. That's not 4. 5, 4 times 5, which means 4 times 5 is 20. Let's verify. 25 squared is, I believe, 625, yes? 15 squared is 225? No, I've done both of those, I think, earlier today. Either that or I have them memorized, one of the two. 625 minus 225 is? Now the square root of 400. Yes. So is it Pythagorean triple?
So it's looking for those patterns.
Yes. And especially on the ACT, if you notice that pattern, especially with the hypotenuse and sides, you'll get to the answer faster, because then we don't have to calculate any of it. Questions on this here? I think we feel comfortable with these, yes? Example 3, let's look at it. The skyscrapers shown are connected by a skywalk with support beams. Use the Pythagorean triple to approximate the length of each support beam. So we know that this is 23.26 meters. This is 47.57 meters. and we want to find the length of the hypotenuse. So a squared plus b squared is equal to c squared. Well, a is 23.26 plus 47.57. Because we're trying to find the length of the support beams. Two sides of the triangle are 23.26 and 47.57. Questions on how we set this up? Is all of this here just a number? Plug it in. 23.26 squared plus 47 point, what was it, 57 squared. Enter. 2803. Point 9325. Lastly, what do we need to do? Square both sides. X is equal to second square root, second A and S. Because A and S is just the previous answer. So 52.95. 52.95 meters. I mean, decimals probably. So this is about a little over 156 feet. It's actually going to be more closer to 158, but questions on this here? Well, there's 3 feet in a meter. So we just multiply it by 3. So do we feel comfortable with this here? Let's look at theorem 9.2, guys. Theorem 9.2, the converse Pythagorean theorem. If a squared plus b squared equals c squared, then it has to be a right triangle. A squared plus b squared equals c squared only works on right triangles. So if it's not a right triangle, a squared plus b squared is not going to equal c squared. It doesn't work if it's not a right triangle. So we want to determine whether this is a right triangle. Which one of these is the biggest side? Root of 113. If we want to make sure, we can just plug it in a calculator. Tell it to approximate, so 11.53. 113, I think I put in. Approximate 10.63. And that is definitely the biggest side, yes? So we're saying a squared, so 8 squared, plus 7 squared is equal to the square root of 113 squared. Now 8 squared is 64. 7 squared is 49. 7 times 7 is 49. 8 times 8 is 64. What's the square root of 113 squared? Because the square root, we're looking for what number times itself gives us 113. And then we multiply it by itself, which just gets us right back to 113. 64 plus 49 is? So 113 is equal to 113. Is this a right triangle? Yes.
Where is
your right angle there?
Because the right angle is going to be opposite the biggest side. Questions on this here?
That could be a 91
Let's look at the next one here. So which side's going to be the hypotenuse? Probably the 4 square root of 95. And it is. 4 second square root 95. 38.98. So that is the biggest side. So we're saying 36 squared plus 15 squared is equal to 4 square root of 95 squared. Now, 36 squared plus 15 squared. Again, we can do these in a calculator. We can let the calculator do those. 36 squared plus 15 squared.
That's just like showing us.
1,500. It's showing that it's the square is not just with the 95, square root of 95, it's with both. Now, so 4 second square root 95. If we put it in without, well, like that. Put it in without the parentheses, let's see what we get. We get 380. Now, if we put the parentheses, 4 second square root 95 squared, because it just squared the 95 and then multiplied it by 4. Nope.
Oh my god. 91 degrees. Wait, is that below? It's 91 degrees.
That's off by 1.
I'm so upset.
Of 15 over. No. Actually, I'll figure out that angle here in a little bit, but it is possible to figure it out. We can't use sine, cosine, and tangent. Purely just sine, cosine, and tangent to find it. Because sine, opposite over adjacent, those only work on right triangles. We would need law of sines or law of cosines to actually figure it out. Plugging things in.
So this is correct after just simply plugging things into the calculator.
Setting them up and then yes. Now let's look at this one here. So the hypotenuse is most likely going to be 12. And we can make sure, say 4 second squared 5. Okay. Delete. It's 8.94. So, okay, 12 is the biggest side. So we're trying to see 8 squared plus 4 square root of 5 squared is equal to 12 squared. Now, again, we could plug 8 squared plus 4 square root of 5 squared, and we'll need to make sure to put parentheses around the 4 square root of 5. And we will get 144. 12 squared is? Yes, it is a right triangle. Because a squared plus b squared is equal to c squared.
So the right angle is top.
Yes. Because if it's a right triangle, 90 is going to be the biggest angle, and the biggest side is always opposite the biggest angle.
Why is this top?
It's just proportions of triangles, sides and angles. Questions on this here? We feel comfortable with these here. The last one we have is the Pythagorean inequalities theorem. Pythagorean inequalities theorem. Well, if a squared plus b squared equals c squared, then it's right. Now, if c squared is bigger, if c squared is greater than a squared plus b squared, is going to be obtuse. If c squared is greater than a squared plus b squared, it is obtuse. All we know is that the angle C is going to be bigger than 90. We don't know how much bigger. It could be 91. It could be 107. It could be 90.01. All we know it's bigger than 90. And if c squared is less than a squared plus b squared, it is acute.
It's already wrote down.
Yep. So let's look at this first one here. Verify the segments 4.3, 5.2, and 6.1 feet form a triangle and is obtuse, right, or obtuse. So that they form a triangle is really saying do the smaller two segments add together to be greater than 6.1. Yes, okay, so it is a triangle. Now 4.3 squared plus 5.2 squared relates to, not 4.3, 5.2 relates to 6.1 squared. That's what we want to see. Is it going to be, which one is greater than the other, or are they equal? Now we can put 4.3 and 5.2 in the calculator. Say 4.3 squared plus 5.2 squared, and see what we get. 45.53. 45.53. 37.21. So, a squared plus b squared is greater than c squared, which means this is it's an acute triangle because a squared plus b squared was greater than c squared. That's it. I do not know.
I get acute being like the small. Exactly. So how the heck is a rubber goose?
You'd be either looking in the Greek or Aramaic languages, because that's where most of it originates from.
No.
A lot more came from actually the Arabs.
I got a lot of it from Greek.
The
Greek robbers from Arabs.
they were advanced. Actually, I meant to say this at the beginning because Pythagoras' theorem a squared plus b squared equals c squared actually wasn't accurate. His actual theorem, because he says that the square of the length of the legs is equal to the square of the hypotenuse for all integers. Integers, no decimals, is what he based his theorem off of, which we know is not true because we've had a few already that aren't integers, are non-Pythagorean triples. The Arabs at the actual same time had the same theorem, but had already proven it's true for irrational numbers. They knew that it was going to be irrational. The easiest one is side lengths of 1 and 1. The hypotenuse is the square root of 2. That are actually already proven that at the same time. So they actually had it more advanced. Yep. And realistically, we wouldn't attribute it to Pythagoras because his society was actually very closed-lipped. They didn't actually divulge or reveal much of anything. The only reason we created or attribute it to it because one of the people in the society actually leaked it out to the general public. This is what it is, so on and so forth. And then they kind of connected it to him. Incidentally, the guy who leaked it actually fell off the side of a ship like a little while after he leaked it. Very coincidental, yes. Now, let's look at this one here. Side length of 3, 4, 6. Well, we do know 3 plus 4 is greater than 6, so it is a triangle. So 3 squared plus 4 squared. Let's see how it relates to 6 squared. So 3 squared plus 4 squared is 25. 6 squared is, so C is bigger, which means it is obtuse. It's an obtuse triangle. Yes and no. A and B, the two smaller sides, are really interchangeable. 3 squared plus 4 squared is going to be the same as 4 squared plus 3 squared. The hypotenuse is always the bigger side. C is always the bigger side. A and B are the smaller side. C is the hypotenuse. Questions on this here? Do we feel comfortable with these here? And that is it. Page 420, 3 through 10, 15 through 18, 21 through 24.